The universal set is defined as X such that X is greater than or equal to 1, but X is strictly less than 13. Again, the universal set is defined as X such that X is greater than or equal to 1, but X is strictly less than 13. The set A is defined as multiples of 3. The set B is defined as factors of 12. And set C contains prime numbers. So basically what this universal set means is that you can have 1, you can have 2, you can have 3, you can have 4, you can have all those numbers, but your numbers have to be less than 13. All right, it has to be less than 13. So you could start at 1 and go all the way up to 13, but you cannot include 13. All right, so that's what this is saying. So the universal set contains numbers that are numbers from 1 all the way up to 13, but you do not include 13. And the sets A and B and C must obey this universal set. So all of the multiples of 3 that you choose, all of the factors of 12 that you choose, all of the prime numbers that you choose must reside within this interval, all right? So list the elements of set A. So we want the multiples of 3. So the multiples of 3 are going to be 3, 6, 9, 12. And then after 12, you have 15. But nope, you cannot do that because it has to be less than 13. And so 3, 6, 9, 12, that is set A that satisfies this universal set. Now we have to list the elements of set B. Now the elements of set B, now B contains factors of 12. And so you have 1 is a factor of 12 because 1 can go into 12 without leaving a remainder. If you have 1 times 2, if you have 1 times 12, that's 12. And then 2, 3, 4, and 6, and 12. The reason is because 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. So all of the factors of 12 are listed here. And it makes sense because, our universal set, you can go from 1 all the way up to 13, but you cannot include 13. So this set does not go over 13, all right? And so this set B lies within our universal set, and that's good. Now we go to set C. So list the elements of set C, and set C are going to be prime numbers that reside in this interval, right? Prime numbers that obey this universal set. So that means that we have 2, 3, 5, 7, and 11. We cannot use 13. We cannot use 19. We cannot use any of those other prime numbers because they are going to be bigger than 13, right? And our universal set, well, our universal set contains numbers that are less than 13. So you cannot go over 13, and it can't even be equal to 13, right? And so that means we only have 2, 3, 5, 7, and 11, and this is going to be the prime numbers that satisfy this universal set. Okay, now we need to list the elements of A intersect B. So A intersect B is going to be all of the elements in which A and B have in common. So we have A listed, we have B listed, and they have 3 in common and 12 in common. So both 3 is inside A and B, and 12 is inside A and B, and also 6 is also inside A and B as well. So the set A intersect B is equal to 3, 6, and 12. Next, we want to list the elements of the set B complement. B complement. So B complement just means that we include all of the elements in the universal set except for the elements in B. All right, so again, B complement means that we list all of the elements in the universal set except for the elements in B. So we have the universal set here. We start at 1, we go all the way to 12. We do not include 13. And B is the factors of 12. And so we just have to eliminate all of the elements of B. And so we eliminate them from the universal set. So that's 1, let's move 2, 3, 4, 6, and 12. And so what are we left with, right? We are left with 5. So we have 5 here, 7, 8, 9, 10, and 11. So 7, 8, 9, 10, and 11. And these are B complement, right? These are the elements in the set B complement. These are the elements that are in the universal set, right? But are not in set B, right? That's 5, 7, 8, 9, 10, and 11. Again, 5, 7, 8, 9, 10, and 11. Okay, next, they want us to write down the value of the number of elements in B union C. So this is B and this is C, and we have to create the union. And the union is basically all of the elements in B and all of the elements in C with no repeats. So this is going to be 1. So 1 is here, and 2, and 3, and 4, and 5, and 6, and 7, and 11, and 12. Again, 1, 2, 3, 4, 5, 6, 7, 11, and 12. Notice that all of these numbers, all of the numbers in the universe, all of the numbers in the union come from the set B and the set C. It's just that you cannot list any element twice. So we have 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4 is there, 6, 6 is there, 12, 12 is here. We have 2, 2 is here, 3, 3 is here, 5, 5 is here, 7, 7 is here, and 11, 11 is here. So the union is going to be all of the elements in B and C combined, but no repeats. But we actually want the number of elements in the union. We don't want the union. So how many elements are inside the set? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 elements in this union. So that means that the number of elements in B union C is 9. So the answer is 9. Next, we have to write down the number of subsets of A. Now, in order to do this, we have to use this rule. And the rule states that the number of subsets that a set with n elements has is given by 2 to the power of n. This is known as the power set rule. So if we have a set that has n elements, that means that the number of subsets it will have would be 2 to the power of n. And so that means that notice we have the set A, and how many elements do the set A contain? This is 1, 2, 3, 4. So set A contains 4 elements. And so that means that the number of subsets, right? The number of subsets of A is going to be what? 2 to the power of 4, or 2 to the power of n, because n is 4, the number of elements is 4. So it's going to be 2 to the power of 4, which is 2 times 2 times 2 times 2, which is 16. And so that means that the number of subsets of A is going to be 2 to the power of 4, which is 16 subsets. And that's the answer to this question. And so this brings us to the end of this video. I'll see you in the next video.